Yeah, can start off. There. So last thing that we did, we have just done with the friction introduction. Like I said, in the whole chapter, there are two things. One, the direction of friction. And the second thing, the magnitude of friction. So what is the maximum? What is the value of friction? F is always less than equal to mu Sn. Right. So you cannot tell the value is directly mu Sn. It depends on the situation. So let's see a few problems from there. I think we will figure it out. Let's start off with something easy and then we'll bump it up. Others, keep your cams on. So we have a block of mass m. Mu is the coefficient of friction. Right now, if nothing is mentioned, if only mu is given, then assume mu s is equal to mu k. Right? If there is a kinetic friction, remember I told you there are two types of frictions. When you're slipping, the friction will be mu k. When it is not slipping, it is mu s. So if nothing is mentioned, then we will assume both are equal. So because in some of the questions, right, you will see they'll just give you mu ka value and then you'll get confused what to use. So we have a block is given speed u on a rough horizontal surface. So you kept a block on a floor and you kicked it. Standard thing. Must have done this many times. Find the distance traveled by the block before it stops. So let me show you one. Step one, draw your FBD. Same story, just like NLM. Draw your FBD. What are the forces? Normal reaction, mg. Since the block is going towards the right, it is slipping, right? Therefore, friction will be backward. This will be F max. So you have to be clear with that, right? Since it is slipping, friction is maximum. If it is not slipping, then you will say, I don't know. Since it is slipping, F is maximum. Acceleration will be backward then. Then F max is mu n. This is equal to mass into acceleration. N is nothing but mg. Therefore, acceleration of the block is mu g. Now it has become a kinematics problem. So we got a block which is going with speed u backward and which has an acceleration a is equal to mu g backward. So as the block will travel, eventually it will stop. Since acceleration is constant, I can use the formula v square minus u square is 2as. This will be 0, this will be u square, 2 minus mu g because it's backward, and this is s. S is equal to U square by 2 mu G. So if you see the whole thing, the only new thing that you did was you found the direction of friction and the magnitude. Easy. So here the ground is at rest. So how do you know it is slipping? So this is one thing. When you say surfaces are slipping, what do you mean by that? Two surfaces in contact are said to be slipping if there is a relative motion. Meaning if the two surfaces have same velocity, we say it is not slipping. Example, let's say A is going with 2 meter per second. B is also going with 2 meter per second. Now see, A and B are moving. So again, people think like there's no slipping, matlab it is not moving. No, not necessary. A and B are moving, but they're not slipping. The simple definition. What do you mean by not slipping? There is no relative velocity. They have same velocity at the point of contact. If you look at here, B and ground are slipping because ground ka velocity is 0, B ka speed is 2, B and ground are slipping. Is that clear, everyone? What do you mean by slipping and no slipping? No slipping does not mean the block is at rest. In this case, since the ground is at rest, eventually when the block stops, there will be no slipping, so friction becomes 0. All clear with this? Let's see same problem. Let's make it a little more complex. So we have the block M, x is equal to 0. Coefficient of friction, mu is e power minus x. So your mu is not constant. Mu is changing with x coordinate. Meaning when x is 0, mu is 1. As x is increasing, friction is decreasing. Surface is becoming less and less friction. And you kick the block with speed u. Find u if the block never stops. These velocities are called escape velocities. If you remember, we did something like this, not exactly this, in that kinematics. The gravity is becoming half every 10 meters, remember? Escape velocity. You will need this integration in case you forgot. E power ax dx is 1 by a e power ax. E is that number exponential, 2.713. Let's get this. Let's see. Right, Samyak. Neresh, man. Let's see. Alexa, stop. I don't know why this Alexa is stopping out of nowhere. Let's see, same story. Let's draw the forces. And mg, again, it is slipping, so this is maximum. And we have acceleration backward. S max will be mu n, that will be mass into acceleration. So mu here will be e power minus x. Mg is equal to ma. A is equal to g into e power minus x. There, NLM got over. Friction and LM both are done. Now comes kinematics. Now here you can clearly see A is not constant. So A will be minus v dv by dx. My minus sign. Acceleration and velocity both are opposite. It's decelerating. So this will be v dv. It just becomes a calculus problem. Integral on both sides. Your initial speed is u. And finally, your speed becomes, let's make it a v, and this goes from 0 to x. This will be v square minus u square by 2. This will be g into minus e power minus x. Limits will go from 0 to x. This will be v square minus u square by 2. Minus minus goes off. E power minus x minus e power 0. So we get v square is equal to u square plus 2g e power minus x minus 1. This is your velocity as function of x. So this v is your velocity after traveling x. Since you go to infinity, as x tends to infinity, v will be greater than or equal to 0 because you don't stop. Since you're not stopping, that means your velocity should never be 0. At infinity, it can become 0. As x tends to infinity, v should be greater than or equal to 0. So u square plus 2g into e power minus infinity minus 1 must be greater than or equal to 0. E power minus infinity is 0. This will become u square minus 20 is greater than 0. U must be greater than or equal to root 20 meters per second. E power minus infinity is 1 by e power infinity, which is 1 by infinity, which is 0. There, if you kick this block with a speed of root 20, you'll never stop. So if you see, once you wrote F max is equal to mu n ma, friction got over. Once you wrote F is equal to ma, NLM got over. Once you wrote A is equal to minus v dv by dx, kinematics is over. Then it is only max. So don't see the whole thing as one big problem. Divide this into multiple pieces. So divide this into blocks. NLM and friction, kinematics and calculus. Looks scary, but physics got over at this point. Clear with this?
Sir,
Dwight.
I did not understand the FBD here actually.
What you didn't understand in that?
That acceleration, it is going behind when you're kicking it forward.
You already kicked it and then you left it. This is not the acceleration when you're kicking. This is the acceleration after kicking is done. So if you push the block forward, force will be which way? Friction will be backward. So it decelerates, right?
Yes, sir. So
Acceleration is backward.
Yes, sir. Yes. Okay.
Vanshika, there is only one force acting in the backward direction. There is no other force in the forward direction, isn't it? So acceleration should be in the direction of net force. And there's only one force, so it should be backward. Got it, Advait. This is not the acceleration while you're kicking. Kicking is done. You already gave speed u. Now you're skidding on the floor.
Yes, sir.
Let's see the next one. Any other doubts on this page? It's more of a max, but anyways, if you're not clear with anything, FBD equations, ask. Next one. So we have a force here, 20 root 2 newtons, 45 degrees. Mu is equal to 0.2. Huh. That is what is written there. Block is already given you. Question starts after kicking. Initially at rest. Find the distance traveled in 2 seconds. Always remember that when they say a block is given speed u, a particle is thrown with speed u, the question starts after the speed is given. We don't care how is that speed given. So someone must be applying a force while giving it. So we don't worry about that. Let's get this. Another standard model. Okay, नेरो हो गया. Right, Aditya. Right, Samyak. Neshman. Neutsa. You guys are doing a classic blunder. Meaning, there is a trap. You fell into it. Step 1, what to do? Draw the FBD. Again, I'm telling you, nothing will change. You will still doing NLM only. Step 1, draw your free body diagram. What are the forces? Force components, F sine 45, which is 20 root 2 cos 45, which is 20. F cos 45, that is also 20. Your own weight, mg, m is 5 kg, 50 newtons. Normal reaction. Block is initially at rest and you're pushing forward, so friction will be backward. What is the value? I don't know. So we will say F only. Getting it? Don't write F max already. Just keep it as F. Now, the most common mistake is this. What is normal reaction? N is not 50. Normal reaction will be how much? N plus F sine 45 is 50. N is 30 newtons. This is the mistake people are doing. N is not 50. Then what is the maximum friction? You need to check. F max will be mu into N. Mu is 0.2 into 30. This is 6 newtons. Since F cos 45, which is 20 newtons, is greater than F max, block slips. Therefore, F is maximum. Now you proved it. Are you getting it? Until unless you prove that you have your force is greater than F max, you can't write F max there in the free body diagram. Suppose just imagine the weight was 100. Then the normal reaction would be 80. Then F max will be 24. Then the answer would be the block doesn't move only. You are applying 20 newtons and the block can provide 24 newtons of friction, then it will apply only 20 newtons and problem is over there. The block doesn't move. So blindly don't write F max in the free body diagram. So there, now we proved this is F max. Since F cos 45 was greater than F max 6. It's like that example I told you. You have 1 lakh and you're ready to give it to me, but I'm asking you 2 lakhs now. So you'll give everything that you have, and you will say this is the max I can do. So then acceleration will be forward direction. F cos 45 minus F max. So you should always check whether the friction will be maximum or not. Mass into acceleration. This will be 20 minus 6 is equal to 5 into acceleration. A will be 14 by 5 meter per second square. You said find the distance traveled in 2 seconds. Acceleration is constant. I can use S is equal to ut plus half at square. U is 0, acceleration is 14 by 5, and time is 2 square. That is 28 by 5 meters or 5.6 meters. Check. So be careful. N is not mg. Don't blindly do that every time. So from the FBD, you have to get the value of N. There is an F sine 45 pulling upwards, so the normal reaction will decrease. All clear with this? So free body diagram, forces, and then kinematics. I hope you're seeing how we are combining everything now. Clear with this? Standard model. Let's see something little different. So let's say we have a surface here. It is rough on the right hand side. It is smooth. I should say frictionless, but yeah, smooth means frictionless. So at this junction here, so after O, it will become rough, and after left side, it is still smooth. So you kept a block here of mass M and length L. And you give speed U to this block. So initially block is on the smooth surface. Right? And after O, it becomes rough. So now if you kick this with speed U, assume it crosses into the region, find the distance traveled by the block. There is a possibility it will stop somewhere in the middle only, even before completely entering. So we are going to assume you have enough speed to enter inside. There is a possibility. If you don't give enough speed, the block can go like this and stop like this only. Some part on the rough and some part on the smooth. We are assuming this won't happen. We are assuming the block will completely enter inside like this. Then find the distance traveled. So this distance I want. Let's see how will you handle this. So as the block is entering, some part is on rough surface, some part is on smooth surface. Something gets messed up. Think I'll give 2-3 minutes. It's a good one. How will you approach this? If it is completely on the smooth, if it is completely in the rough, that is fine. We know how to do that. What if some part is inside and some part is outside? Hope the picture is clear. Length of the block is L. So your answer should come in terms of mu, L, G, and yeah, everything. Initial speed is u. U square by 2mg plus L square by 2mg. Nereshwan, that's not the answer. So how do we approach this? U square by 2mg. So we have to divide the problem into two parts. One while entering and one after completely entering. So let's divide this into two pieces. Let's say while you're entering, now the problem is this. Let's say the block is something like this. So this part of the block is entered inside. Let the distance be x. Let the block travel x into rough surface. So the thing is, the friction will be only due to this part. You're getting it? The normal reaction will keep changing. Remember, N is the normal reaction because of that part which is on the rough surface. You can actually treat this like two problems, isn't it? Treat them as two blocks with a small string connected between them. Can I say like that? I can separate them because the total weight, right, will not be at one single place. Whenever you have a block, the normal reaction is acting actually at every point on the surface. For convenience, we just show one arrow, whereas in reality, the normal reaction is spread over everywhere. It's like standing on both the legs. Where is the normal reaction? It is there on both the legs. So the friction will be only due to the shaded part. So whichever part has entered into the rough part, only that will create the friction. The friction is only due to the shaded part. That means when I draw the FBD of only the shaded part, this distance will be x. So this block of weight also will be different, and it will be small m. So we can use unitary method. For length L, the mass of the block is capital M. For x, the mass of the block is small m. So small m will be total mass by total length into x. That means the mass of the block which is entering is also continuously changing. So if I draw the FBD of this piece, the forces will be small mg, normal reaction, friction. Since it is slipping, this will be maximum. This F will be mu into N. This will be mu into small mg. This will be mu mg by L into x. Your friction is not constant, everyone. The more you go inside, the more friction you're generating. Have a look at this page first of all. Any doubts on this? You should be clear with this part. So the friction is not constant. As the block goes more and more to the right side, more and more surface will come in contact with the ground. So the more weight will be acting on the rough part, so you get more frictional force. Clear with this? Now, if you draw the overall FBD, so due to this part, the friction will be this way, F max, which is mu mg by L into x. So even though friction is only due to the shaded part, but that entire block ka weight is acting. Let the speed be v at this instant. So there's only one force acting horizontally, F is equal to total mass into acceleration. So friction is only due to that shaded part, but the mass is due to the total system, is equal to m into a. So we get an acceleration which is not constant. A is equal to mu gl by x. Clear with this? This is your acceleration as function of x inside. Then A is equal to minus v dv by dx, because A and V are opposite, it is decelerating. This will be mu gl by x. So eventually the block will completely enter inside, then the picture will look like this. So the entire block is inside now. At this point, let the speed be v. So v is the, or let's call it v dash or v final or whatever you want to call. So this v, so the entire block L is inside. So v is the velocity when the block has completely entered inside. So when you take the limits, v dv is equal to minus mu g by L x dx. Initially x is 0, then finally it will be L. This will be initially speed u, finally speed is v. Look at the limits. X is 0, meaning the block is completely in the smooth surface. What is the speed then u? X is equal to L. Block is completely into the rough surface. The speed is v. So this will be v square minus u square by 2 is equal to minus mu g by L. This will be L square minus 0 square by 2. So we get v square is equal to u square. 2 will cancel, minus mu g L. This is the speed of the block. I think this might be right, I guess. Ishman, you might be right. L square. No, but one L is here, no? That gets cancelled. No. Check it out. Have a look at this. Any doubts still here? This will be the speed of the block when it has completely entered inside, which is root over u square minus mu gl. So
can we say from this part that friction is devoid when you surface?
come again, friction is?
Friction does not depend on surface area, because in the end we are just
No.
getting
That is a different thing. See, friction doesn't depend on surface area. When is that statement? If you have a block on a rough surface, if you have another block on the rough surface and masses are same, the whole surface is in contact, na? I still agree, na? Mu is, see, friction is not depending on mu. Here, friction is changing because the normal reaction is changing, isn't it?
Yes, sir. So it's just a coincidence that we got the same answer which we would have got if we had assumed that the friction was same.
Nay, if you have taken friction is constant, you would have got v is equal to root over u square minus 2 mu gl.
Oh, right. I'm sorry, sir. My bad.
You would have got 2 mu gl वहीं पे. 2 cancel हो गया.
Okay, sir.
All clear with this? So this is the speed we got. So here u square must be greater than mu gl for the block to enter completely inside. If u square is less than mu gl, the block won't completely enter inside. This is the first part of the problem when it is entering. Now the second part of the question. So always split the problem into pieces. Now the block has completely entered into the rough surface. And now your speed is v. So now your life is easy. A normal reaction, total weight mg will act. Since it is moving, friction is maximum. Now you get a constant acceleration. So this block will slide, 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 and eventually will stop somewhere here. So v final is 0. So here F max will be mu into n, which is equal to ma. This is mu mg, this is ma. So we get acceleration is equal to mu g. So I can use my kinematics. V final square minus v square is 2as. This is 0, this is v square, this is 2, this is minus mu g and s. Then we get s is equal to v square by 2 mu g. But what is v square? V square is this guy, u square minus mu gl. So we have u square by 2 mu g minus l by 2. So this is the distance traveled on the, this is after entering. So this is the distance traveled inside. So now if you look at the complete picture, this is how it looks. So this is the rough side. This was O. Then the block entered completely here. Then the block went forward and stopped here. This distance was S, which you calculated. And initially this distance was L. So if you just look at the backside has traveled how much? L plus S. So the total distance the block travels is L plus S, which is u square by 2 mu g plus L by 2. Check. So you have to split the problem into two parts. While entering, A is changing. After entering, A is constant. The problem becomes regular. And while entering, it's messed up because as you're entering, more and more area is coming in contact. Again, the problem mu is not changing because of the area. It is changing because of the normal reaction. So you're traveling L on a smooth side and S on the rough side. So total will be L plus S. Any doubts on this? I think this page is the important thing. I hope this was clear. Any doubts? Anyone not clear with anything particular here? There, that's your NLM, calculus, friction, everything. And this is what I keep saying, whatever you learn will keep piling up. Next one. Let's do something a little more easy. We have a wall. We have a block. 2 kg. Mu is 0.5. You're applying a force F is equal to 100 newtons. Gravity is there. Find the contact force. It's a good mains question. Okay. Directions are messed up, right, Soumya? Around 101, right, Arya? Let's see. Step 1, draw a free body diagram. 2 kg block, so 20 newtons. Horizontal force, 100 newtons. Normal reaction. If there is no friction, the block would have come down. Therefore, friction must be up. I found the direction. Don't put F max. Never write F max in the beginning. Always start with F. So what is the value of friction? We don't know. If you write F is equal to mu n, you are doing a big blunder there. That is how the confusion starts. Ask yourself, just wait a moment and say, okay, do I actually know it is slipping? So let's check. So normal reaction is 100, that I'm pretty sure. What is the maximum friction that I can have? Mu into n. Mu is 0.5. That is 50 newtons. So friction is saying I can give you up to 50. But the mg, gravity, is only asking for 20. Since F max is greater than mg, the block won't slip. Now ask yourself, mg is saying, yeah, just I need 20 to, stop the block. Friction needs only 20 to stop the block. I can give you 50. Why the hell will I give 50? So therefore, we need only 20 newtons. So don't put 50. That's what I'm saying. We need F is equal to 20 to stop the slipping. It's like you have 1 lakh to give, but I'm asking only 20,000. Therefore, friction is 20. That is how you always have to check. You can't put F is equal to mu n directly. What is contact force? Contact force is not normal reaction. It is all the forces due to the being in contact, which is root over n square plus f square. You can write it in vector form, minus ni cap and fj cap, but okay. This will be 100 square plus 20 square. 10,400. Check. Most common mistake, people take F is equal to 50 and they finish it off. Or other mistake, people forget contact forces. They think it is only normal reaction like I did. So yeah. Clear with this? So this is the thing that I was saying. Two things you need to do in this chapter. Step 1, what is the direction of friction? How do you do that? If the wall has no friction, the block would have come down. So friction should have been up. Second thing, what is the magnitude of friction? I don't know. If you say mu n, then you're gone. Start with I don't know. Then you go and ask yourself, is it slipping? Okay, it is slipping. Then F is maximum. Not slipping, then it should be whatever is the external force. Clear with this? Easy one. A proper mains level question. They do such kind of stuff. Out of 25 questions, around 10 to 12 questions will be of this level. And most people go for and come. You might find it easy, but in the exam ka pressure, people do all kind of goofy things. Meaning 12 minus 8 becomes 20. So what is this? And this is done by your senior last year. His rank was 713 or something. Advance mein. And that is a mistake he did and came in the advance. He didn't know whether to cry or laugh. Abhi kya kare? My favorite mistake, I told you, 3 into 3 is 6. I did this in the advanced chemistry paper and came. I did that multiple times in my regular practice tests also. I don't know why. Certain things happens, it's a random error. You can't eliminate them. Same thing, let's bump it up. Let's say we have two blocks now. 2 kg block, 3 kg block. This is the side view, this is the wall. Means you're pushing two books onto the wall. You're applying force F here, gravity is there. I hope the picture is clear at the side view. The friction between 2 and 3 is 0.3. The friction between the wall and 3 kg block is 0.2. So frictions are not same. So what is the minimum force so that None of the blocks slip. Find if F minimum if there is no slipping at any surface. Let's get this. $150, $147. Take G in 10, Ray gods. Nothing is mentioned. Take 10 now. Why are you getting such weird numbers? It's not 150. It's not 147. Step 1, free body diagrams. You have to start with your FBD. That's what I kept telling you. If you don't know how to draw your FBD, the whole thing goes off. Let's see whether you got the FBD right. Let's start with the 2 kg block. Horizontal force F. Normal reaction. Your own weight 20 newtons. Now ask yourself how to find the direction of friction. Assume there is no friction anywhere. What will the 2 kg block do? It will come down. Friction does not want to do that. So what will friction try to do? Apply upward F1. Now take the 3 kg block. You get the same normal reaction. Your own weight 30 newtons. This will be N wall. And since F1 is up by Newton's third law, that same friction should act downward here. Now ask yourself, what will the wall do? If this surface is smooth, the block will come down. So this friction should be upward. Please check your free body diagrams, everyone. So if you mess up the directions of friction, then the whole question will go for a toss. Right, Aditi. Right, Samyak. Right, Arya. There, that is the first thing. You need to get your free body diagram right. There, now you got it. Then let's do it. So let's see. So this guy, here F is equal to 100. F, we want to find F. So F is equal to N is equal to N wall. Great. So in the vertical direction, F1 is 20 since it is at rest. Now F1 must be always less than equal to mu into N. And this mu ka value is given as 0.3. So this is 0.3 into F. So we get F must be greater than equal to 200 by 3. Now again, understand this thing. Every friction is like a greedy person. It is only bothered about selfish thing. It is only bothered about F1 will say, I only care about 2 and 3 kg ka slipping. I don't care what the wall does. F2 says, I care only about 3 kg and the wall. I don't care what happens to 2 kg. So the result you got is F is greater than 200 by 3. So if this happens, then there is no slipping between 2 kg and 3 kg. So if you apply greater than 200 by 3, then F1 is telling you, I can make sure 2 and 3 are not slipping. This is no slipping between 2 kg and 3 kg. That's it. F1 doesn't care about the wall. So F1 says, you give me 200 by 3, I'll make sure 2 and 3 are not slipping. Now, when you do the same thing for 3 kg block, now if you look at the forces there, F2 must be equal to F1 plus 30. But F1 ka value is already 20. So F2 is 50. F2 is less than equal to mu of the wall, n of the wall. Mu of the wall is 0.2. N of the wall is F. So this F must be greater than equal to, how much is this? 250 newtons. So F2 is saying, boss, you give me 250 newtons so that I can make sure there's no slipping between 3 kg and the wall. So we got two conditions. So we should take the maximum of this, isn't it? 250, 200 by 3 is how much? This thing comes to roughly around 66.66 newtons. This is 66 and that is 250. So obviously the answer is 250. So if you apply 250, everyone is satisfied. So F is greater than 250 newtons. There is no slipping anywhere. So F minimum is 250. Imagine you give only 200 newtons. Then you know what will happen? 3 kg and the wall will slip, but 2 and 3 will stay together. What will happen if you take both the blocks as one system? Then you will not get this condition. Luckily here you got the answer. What if this value is 340 and this is 250? Then what is the answer? 340, right? You take the bigger out of the two values, whichever is bigger, you take them. Are you clear with that? That is the reason you can't take both as one system. Luckily, you might have got an answer. That is because 3 kg and the wall ka value is bigger. But if 2 kg and 3 kg ka value is bigger, and if you take both as a system, you will miss the thing between them. Is this clear, everyone? How to handle the 2 kg, 2 blocks? Clear with this? Let's see one more. This is another standard model. Definitely have to mug up the result. Question keeps coming, mains, bits, and CET. We have a block M, friction is mu. Find the minimum force required to move the block. This is the kind of a question you'll see in bits. You know the result, you just take it and go ahead. That's it. What is the minimum force? You can apply one force on this block. What is the minimum value required to move this block? Mass is m, friction is mu, gravity g. What is greater than what is the area, Aditi? Right, Arya. Neshman. Neshyansh. Again, who told? Again, tell you one thing. Did I ever tell you the force should be horizontal? Question was minimum force. So I'll give you an idea. Try like this. Let the force be at an angle. So find the force F in terms of theta and then do maximum, minima, or whatever. So the catch here is you're using a part of the force to decrease the normal reaction and you're using the part of the force to move the block. So F cos theta is trying to move the block and F sin theta is trying to decrease the normal reaction. See, when you do a war, there are two ways to attack an enemy, right? There are two ways to win a war. One, you become stronger than the enemy, or you make your enemy weaker. Now, how do you make your enemy weaker? You destroy their supplies, you destroy their logistics, you poison their wells, you kill their crops, you do all this kind of nonsense. So here, that's what is this F sin theta doing. F sin theta is decreasing the normal reaction, so friction ka value decreases. F cos theta is fighting with friction directly head on. So you're playing both the sides. That's what normally what you do in a war. Right, Samyak? Let's see. Free body diagram. F cos theta, F sin theta, normal reaction, mg, friction. So friction will be, since you are about to move, friction will be maximum. So that was a question. Find the minimum force required to move the block. So the friction must have become maximum. So here, first of all, the normal reaction is not mg. This is the mistake. Mg is f minus sine theta there. Then we got f cos theta is equal to f max, which is equal to mu n. N is mg minus f sine theta. Then we get f is equal to mu mg by mu sine theta plus cos theta. So for different values of theta, you have different forces. And you learned this in trigonometry. A sine theta plus b cos theta, you can do maximum minimum also, is less than equal to root over a square plus b square. So if I can maximize this function, then f becomes minimum. Therefore, f minimum. So here a ka place may have mu and b ka place may we have 1. So this is mu mg by root over mu square plus 1. There, remember this.
So can I
And this
suggest
occurs,
a different method for this
you can
question?
see after the class. You can send me your working.
Okay, sir.
Is this clear, everyone? So this occurs when tan theta is equal to mu. For that particular angle, you will get a minimum force. And do remember the result. Standard one should definitely remember this. Exam may takes time. You can do this, but it'll take a minute or two. And if it is an exam like mains or bits or CET, you can just mark it and go ahead. And most common mistake, people do it as mu mg, but and if you see, this is definitely less than mu mg. Clear? With tan theta mu, you can do maximum minimum, differentiate and check it out. Srihari, you know how to do maximum minima, right?
Yes, sir. Like, how did you get tan theta is equal to mu? Like you
So if you
get,
differentiate, you will get it. So you do that.
and then by that we'll get tan theta is equal to mu directly.
When you differentiate it and be equal to 0.
Okay, sir.
You know how to do maximum minima, right? You know, you don't know. You don't
Sir,
know.
I know, sir.
Then just say no. So there, do that. Equal to 0, you'll get tan theta mu. Right? Check it out. This is not school. Each and every definition, these things were done already. School nahi hai. Teacher will not keep telling you, do this, A plus B is that and everything. You guys are preparing for advance. This much you should be able to handle. Clear with this. Take a small break. Come back in 5 minutes. We'll see you here. Any doubts so far? चलो कम बैक इन 5 मिनट्स. हाँ श्रीहरि, वो डिफरेंशिएट करके चेक करके देखो एक बार आ रहा है नहीं आ रहा है.
Yes, sir.
Yeah, let's start off. Chalo, cams on everyone. There we are, 2 blocks here. So we have a block of 10 root 2 kgs. And the other block is small m. 45 degrees and mu is half, which is fixed. Find the value of small m if the system is in equilibrium. Right, Arya. Right, Samya. Neshman. Ne Shihari. One thing I can tell you, see, when you hear the word friction and equilibrium, it's a trap. So when you friction and equilibrium together becomes a deadly combination. Ne. Think, others, give it a try. Again, you're forgetting about something. Friction ka job is what? Friction ka job is to make sure there's no slipping. So I'll give you a hint. There is more than one answer. There are infinite answers. Take a minute, think, then I'll show you. Let's see. Let's take this scenario. Let's say the small m, you keep a lot of weight. You add a very high weight. So if you put a lot of weight here, what do you think will happen to 10 root 2? Will it go up or down? It will go up. Agreed? So we have a case of a maximum case. If m is maximum, then the 10 root 2 kg block will slide up. So now if you draw the free body diagram, What are the components? Mg cos 45. Which is 100. Normal reaction. Mg sin 45, that is also 100. Now, since the block is trying to go up, this will be the tension, friction will be backward, and that will be F max. So N is 100. F max will be mu N, and mu is half, so this is 50 newtons. So we get tension is equal to 150 newtons. And for this block, it will be the same tension T, and this will be Mg. So T is equal to Mg, we will get M is equal to 15 kgs. This is your maximum value, everyone. So anything more than 15 kgs, the block will go up. Let's take the other way around. What if you keep a very little mass? Very little mass. If you keep very little here, what will happen? The system will slide down, isn't it? Then (10^2 kg block slides down. Now, when you draw the FBD, tension will be up. Friction this time will be upward. You're getting what is happening? The friction is changing its direction. This is 100. Normal reaction, this is 100. Same story, F max will be 50. In this scenario, we will get tension is equal to 50 newtons, which is equal to small mg. So we get M is 5 kg. This is your minimum value. So anything less than 5 kg, the block will go downward. Anything greater than 15 kg, the block will go up. That means anywhere between 15 to 5, you are safe. So you get a range of values. Is that clear, everyone? So whenever you hear the word friction and equilibrium, remember you always get a range. So let me show you an example with this. So when I take this incline, look at the numbers here. Huh? So we know friction can give you maximum 50. Now remember, maximum 50. Now just look at the words here. So tension is up T. This guy is already 100. Let's say if you're applying T is equal to 100, can you tell me what is the value of friction? If T is equal to 100, what will be the friction? 0, right? There is no need to apply anything. What if T is 110? Then friction will act backward and F will be 10 newtons. What if T is 130 newtons? Then friction will be 30 newtons. What if T is 150 newtons? Then friction will be maximum 50 newtons. Are you getting what is happening? Depending on how much weight you are keeping, the friction is also adjusting its value continuously. This is what we did in the beginning. Friction can change direction, can change its magnitude. Are you clear with this? Similarly, if you go the other way around, let's say your tension is 90 newtons. Now the block will try to go down because mg sin theta is dominating. Your friction will come upward to support you. So if T is 90, then the friction will be 10 newtons upward. If T is 70 newtons, then friction will come and give you 30 newtons. If T is 50 newtons, then friction will give you maximum 50 newtons. I hope you can see this, what is happening. The friction can change direction, friction can change magnitude. So at 5 and 15, it is at the extreme limit. So any value between 5 to 15, you're safe. All clear with this? Anyone confused with this? Hi, Ishman. Clear with this? Let's see one more. That's a pretty good problem. Most people write either get 5 or 15. If it is a more than one choice question, I'll give you options like 6, 9, 13, and 17. And most people will think 5 is not there, 10 is not there. They get confused what happened. But the answers are 6, 9, 13. That's how you'll get trapped. That is one good one. Let's see one more. So let's say we have an incline, we have theta, let's say mu is less than tan theta. You projected this block with speed u up the incline. So this block will go up and then it'll take a turn and it'll come back. Find the ratio of time of ascent by time of descent. Straightforward kinematics question. So you're kicking the block up the incline, it goes up and then it comes down again. So find the ratio of time of ascent by time of descent. Others need to keep your cams on. Right. This is not a tough one, but it is a lengthy one. Involves little working. Just figure out the direction of friction. While you're going up, friction is which way? Down. While coming down, friction is which way? Up the incline. So friction ka direction changes. Right, Shaurya. Right, Arya. U by G. नहीं श्रीहरि. Dimensions match नहीं हो रहा है तेरा. Let's see. So while going up, draw the FBD. What are the forces? Your mg sin theta is acting downward. Again, I'm only taking the forces along the incline. Since it is slipping, friction also will be maximum backward, which is mu mg cos theta. And deceleration will be backward. Let's call it A1. So from here we get A1 will be equal to g sin theta plus mu g cos theta. So mg sin theta plus f max is equal to ma. That's your acceleration. So this block will go here and eventually it will stop somewhere here. And let this distance traveled be also s. So we get v is equal to u plus at. So we get this will be the time of ascent. So this v will be 0, this will be u, this will be minus a1 into this will be time of ascent. Therefore, time of ascent is u by a1. And what about this distance traveled also? V square minus u square is 2as. V is 0. This is u square. This will be 2 minus a1 into s. This is the distance traveled. This is the situation while going up. So you will travel a distance of s and then stop there, and it will take a time tu by a1 to reach there. Now, while coming down, you will not come down with the same speed and you don't have the same acceleration. The whole picture has changed. When you start sliding down, the friction is upward now. And this is your acceleration a2. Now a2 becomes g sine theta minus mu g cos theta. So while going up and coming down, you don't have the same acceleration. So I can't use v is equal to u plus at, because when it reaches the ground, the speed is not 0. The speed will be some v dash, which I don't know. So you can't use v is equal to u plus at here. But I can use s is equal to ut plus half at square, because s is still the same. So s is equal to ut plus half at square. S will be the same guy, u square by 2a1. Initial speed was 0, acceleration is half a2. This will be time of descent square. So from here we will get time of descent will be u by root a1 a2. Check. That's your time of ascent and that's your time of descent. Please have a look at the equations. Now the ratio I'm asking. So from there you'll get in the ratio of some root a2 by a1 something, and then we can substitute a1 ka value and a2 ka value. But have a look at this page. Yeah, then time of ascent by time of descent. This guy is u by a1. This is u by root over a1 a2. This is root over a2 by a1, and a2 by a1 is what g will cancel anyway. So you'll end up with root over sine theta minus mu cos theta by sine theta plus mu cos theta. You can divide denominator and numerator with cos theta. And it becomes tan theta minus mu by tan theta plus mu. It's more of a kinematics question, but yeah, you need to get the directions though. Are the steps clear, everyone? Next one. Any doubts on this? So here we define something called angle of repose. Again, terminology is more important. Questions are manageable, but the terminology is important. They'll simply say this is the angle of repose. So then you should know what they're talking about. This is theta. So if you take a block here, and if you look at the forces, we have friction, we have normal reaction, mg cos theta and mg sin theta. If the block is at rest, again, be careful, don't say F is maximum. If block is at rest, friction is equal to mg sin theta. That's why it is at rest. Friction is balancing mg sin theta, and friction ka value should be less than equal to mu1. So this will be equal to mu into mg cos theta. So from here we will get tan theta is less than equal to mu. So this angle, right? So this is the condition for no slipping. So if mu is greater than tan theta, the block won't slip. So we define this angle theta, tan inverse mu is the angle of repose. So is the angle at which the body is about to slip. F is maximum. So if you exceed this angle, the block will slide. So for example, if someone says mu is equal to 1 by root 3, then the angle of repose is 30 degrees. Means if the incline is greater than 30 degrees, the block will slide. If angle of inclination theta is greater than 30 degrees, block slides. That's what it simply means. Clear with that? So we have few applications of this. So questions will be like this. If you ever gone to a beach or something, and if you try to, when you're playing there, you must have made a sand cone. So there are a few cases on this. Height of a sand cone. So what decides how high the sand cone will go will depend on the friction. So let's say if you're making a sand cone, and if you take the sand particles, and if you look at the forces on the sand particles, we have friction upward, and this mg sine theta is dragging it down. This is theta. This is the height of the cone, and this is the radius of the cone. So when it is about to slip, this friction will be maximum. Same story. Basically, this will come out to be angle of repose. So tan theta will be mu, which is equal to h by r. So the height of the cone will be mu into r. Now, because beach ka sand, right, is very smooth and they have very less friction. So since mu is very small, if you want to get more height, let's say beach ka sand is 0.1. That means the height will be 0.1 times radius. So if you want to make a 1 meter ka height of a sand cone, you need to make a base of 10 meters. But imagine instead of beach ka sand, if you're using clay sticks together very easily. That's what you make statues out of it, isn't it? So if you have clay, and let's say clay ka friction is pretty high, let's say 0.9 or 1, that means even for a radius of 1 meter, you can create a 0.9 meter ka height. You can get more sharper peaks. So it depends on the sand. If your sand is very smooth, the cone becomes pretty, wide. So height of a sand cone depends on the coefficient of friction. Basically, that's your angle of repose. Another way of asking this question was insect walking in a bowl. So let's say you have a bowl, right? Again, we are talking about a regular human, like, let's say when I say insect, don't think about a lizard and all these things. Huh? These things, legs have something else. They have suction cups. So when they're actually, the legs stick to the surface. We're not talking about those kind of insects, maybe an ant or maybe a rat. So if a rat or something is trying to walk on this, again, like I said, the reason an insect can walk is because of friction. So friction is dragging you up. So if I take you and throw you into a hemisphere, the same thing happens with you. This is mg cos theta. So the maximum angle you can climb is tan theta is equal to mu, angle of repose. So after reaching this point, the mg sine theta dominates friction, it slips. So if someone actually takes you and really throws you into like this, you really can't climb this by walking like this. So what you do is actually you start running in circles. Then you can get out. That comes in circular motion. So when you start running in circles, you get a centrifugal force that will actually increase your normal reaction, and that friction will increase, and then you can come out. Right? So check it out. So basically it's an insect walking in a bowl. That is one more case. Another case, this I showed you in calculus. We have a hemisphere. So all these things will be literally a question each. Radius r, and let's say friction mu is equal to √3. So you took some dust here and you sprinkled it on a hemisphere. And then what happened? Because of this dust, a part of the area got covered in dust. The question is find the area covered in dust. Anyone remembers how to do this thing? Try, I'll give you a minute. You took a hemisphere whose friction is mu is equal to √3. And you sprinkled dust on it, and the dust got stuck to the hemisphere only for a part of it. The entire thing didn't get covered. Find the area covered in dust. In case you forgot, this was the result, remember? We did this in calculus. Don't forget this 2 pi r square 1 minus cos theta. And this is the same example I gave. That's quite an important result. This you will see another 3 more times after friction. So same story there. The reason why the dust particles are only going till a certain part is because, again, angle of repose. After this angle theta, if you look at the forces here, again, this is F max. So any particle after this, mg sin theta dominates. Tan theta is equal to mu. This is √3. So theta is equal to 60 degrees. So this is an easy part. The headache is the area part. If you don't know that calculus ka thing, you won't be able to solve this. This is 60 degrees. So this is the area covered. The formula is given by 2 pi r square 1 minus cos theta. This is pi r square. This you can see in calculus page 134. That formula comes from there. Clear with this? Yeah, that's how you can play with the angle of repose. So, let's say you want to catch rats. These Jains, right? They don't want to kill any animal, but rats are still a menace. So there is a Jain rat trap. It looks like this. So it's like a bottle kind of thing. So they keep some food or something here. So when the rat comes inside and it starts climbing inside, this jar becomes straight. And the rat is trapped. So as it is climbing inside, once it goes inside, it's like a seesaw kind of thing. So once the weight comes here, this thing goes up and becomes vertical. You can catch the rat without killing it. Then you go and throw it out, and eagle or crow will come and take it away. So safe. Anyway, so that is one way. So let's do a question based on this. Instead of a bowl, let's say we have a curved surface. Let's say y is equal to x cube. And let's say mu is equal to half. And this rat or an insect tries to climb. Find the maximum height it can climb.
Sir, how y is equals to x cube can be equation for this?
Why? What is the problem? Okay,
Sir,
that's what you're saying.
yeah, like
Ah,
it should be like minus x cube for one
Hmm.
x.
Get it. Let's get this. So we have an insect here which is climbing on this random surface. What is the maximum height this insect can climb? Let's see. Some you have got an answer. Anyone else? Arya got something else. Srihari, Samyaki both got the same thing. Anyone else? Shriyansh, I think yeah, all three of you got the same answer. Arya, check your answer. 4 people got the same thing. Okay. So same story. So this insect can climb up to maximum angle of repose. Someone is wrong, definitely. Let's see, we don't know who is wrong. So let's say at some point here, you can treat this as an incline, draw a tangent. And let this angle be theta. Tan theta is nothing but dy by dx. So you can treat the entire curve as a, inclines at different angles. This will be 3x square, right? And the maximum angle it can climb is up to angle of repose. So the insect slides when the tangent makes an angle equal to angle of repose with the horizontal. So this angle should become angle of repose. So angle of repose is nothing but mu. So mu is half, which is 3x square. So we got x is equal to 1 by root 6. So this coordinate is x comma y. So the height will be the y coordinate, which is x cube, which is 1 by 6 root 6. There, that's your answer. Clear, everyone? So it doesn't matter whether you're in a bowl or anything. Arya, clear, na? See where
Yes,
you
sir.
messed up. X square ले लिया क्या?
Sir, actually, I took the dy by dx part. Tan theta is y by x, which is x cubed by x.
dy by dx, na differential.
Yes, sir.
All clear with this? Easy. So it's all based on angle of repose. It doesn't matter whether you're going a bowl or in a curve or anything. You can go maximum up to that. Let's see one more. If you see today, right, we are all doing some basic questions. Matlab, you will get them in 3-4 steps. Maybe a few calculations, but not much of a calculus and all that stuff. Next class, we have some pretty good ones. Where are you, friction? Let's get this. Always the same story. Start with an FBT. Again, this is more of a geometry problem. Try. I'll give 2-3 minutes. Give it a try. I'll just get some water and come. One plus mu by 1 minus mu ne area. Nope, that's not the answer. I think you guys are goofing up the geometry part. Try. I'll give you a minute more. So if you draw the FBD, how many forces are there? There'll be 2 normal reactions, 2 frictions, 1 mg. Totally 5 forces. Ne area, that is still wrong. Meaning, see, if you put mu is equal to 1, you're saying r should be 0. Let's see where you guys are voting up. Let's see whether you got the FBT right or the calculations. So this rod will be a tangent. So this will be normal reaction N1, N2. Sorry. This will be friction F1. This will be friction F2. This will be mg sine theta. This will be mg cos theta. We will find that theta. So if you extend this line here, this will be theta. So if you look at the forces here, N1 plus N2 is mg cos theta. I don't know N1, I don't know N2. We can find them using rotation, but we don't need it right now. And F1 plus F2 is mg sine theta. Since it is about to slip, both the frictions must be maximum. If the statement is it is not slipping, then you can't say, you can't solve the problem because the values can be anything. F2 max will be mu2, mu n1 and mu n2. So this will be mu n1 plus n2 is mg sine theta. But n1 plus n2 is mg cos theta. Again, we got the same thing, angle of repose. Clear? Now, I think you must have got till here. Then, if you got till here, then you goofed up the geometry only. So that's a tangent. So this is theta. This is 90 degrees. This is radius r. This is 90 degrees. This is small r. This is also small r. This is also scapular and small r. So from here, if you drop a perpendicular, so if you see that triangle there, this is also theta. So I'll just draw the triangle again. So I'll just name these points here, A, B, and let's call this thing C. So if you draw ABC, so this length will be r plus r. This length will be r minus r, isn't it? That length is r minus r. This difference in radius will be r minus r. Sure, everyone. And this is theta. So here what we got is sine theta. Sine theta is r minus r by r plus r. It's not tan theta. Clear? And then you're done. And we know tan theta is equal to mu. So make a triangle. This is theta. Tan theta is mu 1, and this opposite side is 1 plus mu square. So sine theta will be mu by root over 1 plus mu square. This is r minus r by r plus r. You can do that componendo, dividendo, and whatever not. Or you can do cross multiplication, anything. Then if you do that componendo, dividendo, what can I do? This will be mu plus root over 1 plus mu square. Mu minus root over 1 plus mu square. This will be r minus r plus r minus r. That will become r by R minus R, this will be minus R. So send the minus that side, you will get the answer. Clear with this? So the final answer is this. R by small r is root over 1 plus mu square plus mu. Check. I think maybe you goofed up the geometry, but clear with this? Yeah. So I hope the FPD was clear, na? If you have got till here, I think it is fine. Like geometry part, it's okay. You will figure it out. So that's not tan. This is not the opposite side. This is not the adjacent side. This is the hypotenuse. All clear with this? There, that's a bit about this. There we have done almost 10 problems today. So next class, when we catch up, we'll continue from here. We are going to do more complex ones. We're going to do 2-block problems, slipping things and everything. If you must have noticed one thing, the whole chapter kind of looks like laws of motion, isn't it? The only thing is you need to get the friction guard direction and the magnitude. Rest of the question will just become an NLM. So next class, we'll continue with this on Thursday when we catch up from here. But I think we will wrap up this chapter next Tuesday. We'll finish off this in another 2 classes. It's not a big chapter. And after that, we'll start off with circular motion. So do start solving, right? I hope NLM ka, you have finished whatever, your class booklet material that you're solving, finish it off. Did I send you a sheet on NLM also?
Yes, sir. You
I
sent
think I
it.
sent. So yeah, that will be additional practice. You can do that. Okay, with that, we'll wrap up for the day. And this week, a test is online. So do make sure to give it. So any doubts in the class notes, any other doubts, please stay back and ask, or else you're free to leave. So take care, stay safe. I'll see you guys on Thursday.